everyone, welcome to the session on Genius Shock. And today we are going to continue with the next part of number system where I'll be bringing you important previous year questions. So let's start the proceedings. First is this one. You can see this is a series given, and here we have to find the sum of the squares of these series. So see, if you can do this question randomly also, like if you remember the squares, so 11 square 121, it is 144, but it will take some time, because for that you must be a good observer of the squares, plus you must be very good with the addition part. This calculation must be really fast. You can do like 14 square is 196, 15 square is 225, 16 square 256, 17 square 289, and then 18 square that is 324, 19 square 361, and then 400. You can calculate. The problem is if you added the last digit is 5, 9, 14, 6, 20, 25, 31, 40, 44, 45. So last digit is 5. Again, you need to add it. So this is one way, right? An easy way you can solve this question. Just add like this and get the answer. But as we do this question approach wise, so we know that we have a formula that is from 1 square, 2 square, 3 square up to n square. The formula is n into n plus 1 into 2n plus 1, and that is by 6. So we need to apply this formula here. Now the important information you must focus here is that here the numbers, the series is not starting with 1, they are starting with 11 and they are ending in 20. So what we do is we'll add this extra part which is not here. So what I'll do is, and this I'll solve mentally, right? Here I'm solving just to demonstrate you, but in that you have to just put the values. So I'll add here from 1 to 10 square, and after 10 I have this series given already, which is starting from 11, of course. So 11 and then 12 and so on up to 20. In mathematics, if I add something and if I subtract the same, it remains the same, right? So the same concept. Now I'll subtract the same. This part I have added and this part I'm subtracting now, just to make the things easy. All right. Now if you see focus, you will observe that this is from 1 to 20, right? And then this is from 1 to 10. Now you can apply this formula from 1 to 20, and then you can use it for this from this 1 to 10 square. So we'll solve it now. So from 1 to 20, what is the formula? The same formula we'll use, this one. So this is going to be this is n is 20, 21, which is n plus 1, and 2 into 20 plus 1, that is 41 by 6 minus. So this part we have got, right? This part we have got. And next is we'll use this 1 to 10. So this is 10 into 11 into 21 by 6. Now if you take something same, that is you can see 21 by 6 is same. You can solve the rest. 20 into 41, that is 820, and you can solve it. 10 into 11 is 110. So this is going to be 3 to the 6, 3 7s are, then 7 by 2, that is 0, that is 9, and that is this is 0, sorry, this is 1. So this is 0, 1 and 7. So you can just multiply it. 3, 5, 5 into 7. This 7 is not cancelled. Yes, this is there. You just multiply it. 350 into 355 into 7. So this is 7 5 is 35. Or you write like this: 350 into 7 and then 7 into 5, 35. So this is 7 5 is 35, and this is 2450, and this next is 7 5 is 35 is left, so 2450 plus 35 mentally is 2485. So this is another way by which we can solve this question formula wise, right? So this is the next approach, although you can solve this question directly also, but the problem is, suppose instead of 11, see why we use this trick. Suppose instead of 11 this is 41, then it is very difficult to solve. Or say it is 191, then we have to apply this sum formula. We'll add this extra part here and we'll subtract that extra part here and we'll have the answer. So this is the benefit of this formula. Now go ahead, going to the next question. If this number is divisible by 6, what is this hash? So it is quite easy. For divisibility rule of 6, we need to, because 6 is a composite number, it is composed of 2 and 3 which are both prime. So we break it in terms of prime numbers and then we'll decide like this: 5 hash and 2. Now you see, for divisibility of 2, we need to have the last digit of any number. Suppose I write 647, so it is not divisible by 2. Why? Because the last digit is not even. So for this we need to have 648. Now we can see this is even, so this number is divisible by 2. So similarly, if you see this number 5 star 2, 2 is the last digit where 2 is even, so I can say this number is divisible by 2. So this is divisible by 2. I need to check it for 3 now. So go ahead. So for 3, I need sum of the digits must be divisible by 3. So find the sum of the digits. 5, suppose this is x plus 2, so this is 7 plus x. Tell me which value you can give to x so that this number is divisible by 3. So obviously it is 2. 7 plus 2, that is going to be 9, and 9 is divisible. So what value I can give here as per the options also? It is second option, right? So this is how we approach this. Next, which of the following numbers will completely divide this part? 49 to the power 15 minus 1. So let's use 49 to the power 15 minus 1. This is what we have the question. So we have to break this power in such a way so that the number is divisible by any of these options. Our work is to find the answer first. So what we'll do is, we'll try to break, it is 7 square 49 and this is 15 minus 1. So 7 square is, these power need to be multiplied, because the rule is a to the power m and to the power n, that is a m into n. So that has to be 7 to the power 30 minus 1. So we have finally converted it like this: 7 to the power 30 minus 1. Now you know the rule, x to the power n minus 1 is divisible by x plus 1 as well as x minus 1 when this n is even. Let me give you an example here. Suppose I write it like x square minus 1, and I can write 1 as 1 square because 1 square is same as 1, and this is divisible by, obviously, because the formula, right? A square minus b square equals to a plus b and a minus b. So we need to use this formula here, right? So let's use it here. It can be written like x square minus 1 can be written like x plus 1 and x minus 1. That means if this number can be written like this, that means this is divisible by both also, right? So this is the reason we say that if this n is even, this number is divisible by both. The same concept I'll apply now. So you see, here I have this part, 7 to the power 30 minus 1. Okay, now this power is even. Now what we do is, 7 to the power 30, can I write it 1 to the power 30? Yes, I can. And this is divisible by 7 plus 1, where x is 7 and 1 is this one is same as 1, and this divisible by 7 minus 1 as well. So can I say this number is divisible by 7 to the power 30 minus 1 is divisible by 8 and 6. So which option we have here? 8. So that is my answer. If 6 could have been there, we can see that is also the answer. But here because as per the options we have 8, so we'll not use 6. So that is the answer. That is first option. A beautiful question, I guess. Next, now we need to add these numbers and tell the answer. Of course, this is a big number. So what we'll do is we'll try to. So first, what is the method? See, the method is first take the complete numbers. So I'll open it up. 9 plus 3 by 4 plus 7 plus 2 by 17. Now I'll take this minus sign here inside. Minus 9 by 15. Now apply the concept. Concept is add all the integers separately and add all the fractions separately. So if you add it, it's going to be 9 plus 7 minus 9 plus 3 by 4 plus 2 by 17 minus 9 by 15, right? Now this is cancelled. So 7 plus, that means your answer is not this second option and not this third option, because we have 9 as the beginning. Although we still need to check, because it may be like if something is something more is coming, we can add it up. So let's say let's leave it like this and go ahead. 2 by 17 minus 9 by 15. Now you know what to do. We need to take the LCM of these numbers. So I'll not take directly the LCM. What I'll do is, because these are not cancelled, 4 is not cancelled, 17 is not cancelled by 4, 15 is not cancelled by 4, and 17 also. So I'll write the LCM like this. See the approach, right? Okay, 7 is already here. Now 4 is divided by this, so 4 is cancelled, 17 and 15 is left. So can I write 3 17 into 15? Okay, next 2, 17 is there, 15 and 4 is left, 15 and 4 is 60. So 2 into 60 minus 15 is there, 17 and 4 is left. So this is going to be this is minus 1. So please take it minus 1. We have written it wrong here. It has to be minus 1. All right, 1. So 15 is here, 17 4 is 68. So 1 into 68 is giving you 68. Now add it and solve it. So you have 7 plus. Now multiply it. What do you have? 7 plus, and this is going to be 3. This is 15 7s are 105, 10 and 255 plus 120 minus 68, and this whole is divided by 4, 17 and 15. Now solve it further. 215 to 3 750, 750 plus 3 5s are 15. So 750 plus 15, it's 765. So 7 plus 765 minus, what is it coming? 120 minus 68, that is 2. And here we have this is 1152, right? I guess this is the answer, because 60, 8 is less, and this is 4 17 15. So you can check the answer now. It has to be 7 plus. What is left? This is 68. This is 120. Oh, sorry, this is plus 52. So this has to be 7. This is 11, and this is 8. And every option is having 1020. So that is very clear that if we multiply this, we'll get 1020. So guys, this is the answer of the question. This is the answer of the question, which is your fourth option, of course. Right, so this is the approach. Take the integers first and then take the fractions and then solve it, right, in the manner you know. Next. All right, we have another question. It's like the same series. So here again, if you open it, you'll get this 1 with 1 with 1 up to n times. So can I write 1 plus 1 plus 1 up to n times? So if I add 1 n times, the answer is going to be n, right? Next, focus. Take minus common now and focus on here. These parts, this part, and this part. So this has to be 1 minus n plus 2 by n plus 3 by n and so on up to n terms. Now this completely has been solved, so this is definitely solved. This is n, right? So I'll taken it as n. Now focus here, this n is common everywhere, so can I write minus 1 by n common? Yeah. Now what is left inside? 1 plus 2 plus 3 and plus up to, right? This is n only, right? This is n. These terms are common, so I have taken it out. Now if you solve it, we have discussed a formula. What is the sum of the first n natural numbers? That is given by n into n plus 1 by 2. So you can cancel this n. What is the answer? The answer of the question is n minus n plus 1 by 2, and that has to be 2n minus 1 by 2, and that is 2n minus n minus 1 by 2, and that is the second option, right? So this is the approach of this question. All right, next, on dividing 2272 as well as 875 by a 3-digit number, and we are getting the same remainder. So what is the concept? Let's check. Suppose I take a number, say 75, okay, and I'm dividing it by 18, right? Then I take say 57, I am dividing it by 18. Here 18 is a 2-digit number. I'm not taking a 3-digit number like here. I'm taking a 2-digit number. So if you divide it, you will get a remainder 3, right? And here also, if you divide 18 3s are 18, of course 18 4s are 72, so 3 is left. Then 18 3s are 54, so this is 3 is left. That means there is one more concept which is coming out here, that is, if I subtract 75 and 57, that is what? It is 18. This is also divisible by 18 and giving remainder same, right? Or you can say, if I take the difference of these two numbers, right, then also they will leave the same remainder, because 75 and 57, they were giving the same remainder, right? So this is the concept, that we need to subtract both these dividends, because they are being divided by a same number and they are leaving the same remainder as well. That means if we subtract them also, right, like if suppose you take next multiple, what is 18 5s are 90, if you take 93, right, 93, and suppose it's 57, then also if you see, it is 6, again it is divisible by, this 18 was divisible by 18, right? 36 also divisible by 18. So that means we can take the difference here. You take another number also, like if you take 18 6 108, so you can take 111 and say you have taken 57. If you subtract 54, again divisible by 18, leaving no remainder. So all these three are leaving no remainder. So what we need to do is, we need to subtract it. So this and this, subtract, what you will get? Because if you subtract it, because these numbers are divided by the same number, this is also divided by the same number, and we are having the same remainder. That means if you subtract it, then we'll not be having any remainder, right? So this is the concept applied. So if you subtract it, you'll be having 7, then 9, then this is 16 7 9, then 11, but you have 1 3 9 7. Now this is what you have. Now this number is divisible by what? That we need to check, right? Because if we divide this number by that 3-digit number, it will give me a remainder 0. This is the concept. So like we did for this 18 multiple, right? So taken the difference. Now what is the difference? That will, whenever we divided by this number, must be giving me a remainder of 0. Now I need to check what is this n. That means by which number I can divide this 1397. So let's check what is the concept. So if you divide it, so just try to check the divisibility rules. Is this number divisible by 2? No. 3 is 4 plus 9 13, 13 plus 7, 20 is not. By 4, last two digits, no, it's not divisible. By 5, last digit is 0, no. 6, last digit is not even, no. 7, if you check 7, again it's not. Then 8 is not, because last digit is not even also, and even the last three digits we need to check for 8, but here the last digit is not even, so we can't check. 9 as same as 3, so no. 10, no. Then 11, check for 11, guys. What is the rule for 11? The sum of the digits at odd places, first place, third place, that has to be 10, and this second place, fourth place, that has to be 10 again, so that is 0. Yes, this number is divisible by 11. So what we need to check, we'll just write it like this. Can be written as 11 into 11 ones are 11, or you can write it like this also. Subtract 11 ones are 11, and 2 9, 11 twos are, then 127. So this can be written like 11 into, this is 1397, which we can write like this. That means this must be divisible by 11 as well as this. So what is the answer? We can see the answer is 3 digits. That means this number, if you divide by 127 11 times, and it will give you 0 remainder. So my answer is 127. It is asking you the sum of the digits. The sum of the digits, sum. So what is the sum? 1 plus 2 plus 7, that is 10. 1 plus 2 plus 7, and that is 10. So the answer of the question is 10. Right, so this is the way. Next, similar type. A boy multiplied 987 by a certain number and obtained this as the answer. That means we have a number. What is that? Let's write it. Suppose we have 987, and a boy is multiplying with some other number, and he's getting the answer 55, in which 2 9s are wrong. If the answer, in the answer both 9s are wrong, other digits correct, that means these 2 9s are wrong, rest is. So we need to find these two values. Actually all these are same, right? You can see. So we need to find which value out of these options is these. So these all 4 are same. So let's find. So if you see, if you have multiplied this by any number and you are getting this, if you are getting this, so what is the way? First we need to find that this 987 is, divisible by what. So try to make the factors of it like this. 987. Now think about by which number we can divide it. 2 no, 3 no. 3. Yes, I can see 3. 3 3s are 9. 3 2s are 6. 3 9s are 27. Next, it is not 3. It is now 7. 7 4s are 28, and 7. So this is a factor, 3 into 4. So that means I can write 3 into 7 into 47. Now guys, we need to check now if this number n we need to find, right? That means this must be divisible by this, this, and this. So let's check for 3 which number is satisfying out of the options, because if this see, this is a complete number, right? If I'm multiplying this 987 into n, that means this is a complete number, which is this, and this number must be divisible by all the 3, 7, and 47. So I'll check with 3, the basic one. So for 3, the divisibility rule is sum of the digits has to be divisible by 3. So let's check which option is satisfying this. So for 3, 3 6 9 819 correct, but 559 it's not correct. So A is cancelled. Next. So next is 555 15 done. 819, but still 1 left, so it is also cancelled. 555 15 fine. 6 fine. 819, yes, this option is correct. You can see the fourth one. 6 is correct. 819 is correct. 5, and here you have 6 is correct, but the problem is it is. Now if these two are confusing, because the last digit, see this number and this number. Let's check for 3 again. See 555 15, and 681, all are cancelled. 5, 5, 5, 15, 681. Now our next is to find this number by 7. So are these divisible by 7 also? Because for 3, these both are divisible as both digits are same, right? So let's find which number is cancelable by 7. So if you find, let's see, 7, if you divide it by 7, you divide 5, 5, 5 and 6, 8, 1, right? What is the rule? What is the divisibility rule of 7? That is, the first, you can pick the pairs like last 3 pairs and this, and subtract. Write this in pairs of 3, write this in pairs of 3. Now get it. 11 minus 5, 6, and 7 minus 5, 2, and this is 1, 126. Now for 3-digit number we have a rule, 12, pick up the first 2 and then the third, take the double of the third. So 2 into 6, that is 0, and this is cancelled by 7 because the difference is coming out to be 0, right? So this answer is C option. If you check the fourth one, let's check. It is again, you need to be very clear in your rules, then only it is viable to solve. Check for fourth. 5, 5, 6, 5, 8, 1. So pick up the pairs from the last in 3. So 581, 556. If you subtract it, it is 15. It is 2. 25 is not divisible by 7. So this is not my answer. So what is the answer, guys? The answer of the question is third option. A beautiful question, a beautiful concept, right? All right, next. Question number 8. We have, when a number is divided by 13, the remainder is this. When the same number is divided by 17, then the remainder is 9. So this question is best solved by the options. Pick up the first option. If you divide 339 by 13, are you left with the remainder 11? Check. 13 2s are 26. Now what is left? It is 139. No, remainder is not 11. So this is incorrect. Similarly, check the second. Obviously, if you check this by 17 also, this will not satisfy. 339 by 17. So 17 ones are 17. If you take the difference, that is 169, and 17 tens are 170. Again, not cancelling. So this is not clear. Go with the second option. 349. 349 divided by 13. Now what is left? Check. 13 2s are 349. You can check this way directly also. 13 2s are 26, and it is 8. So 13 6 are 78. So 11 is left, and this is what we require. Yes, very good. Now go and check for 17 as well. So 349 by 17. You can see 17 2s are 34. So this is cancelled. 9 is left, and we require only 9. So guys, this is the answer, second option, right? This is the approach of this question. Next, again a sum question. Now it's a beautiful one again. 1 to 100 we know, so take it, whatever extra is required, take it, because it is not starting with 1. So we need to start it by 1. So if I add this from 1 to 50, right, in this series, and again from 51 to 100 already I have been given, so my work will be quite easy now, right? And here minus this, so this is going to be 1 plus 2 plus 3 plus up to 50. Now you know the formula, sum of first n terms. Because of that only we are making this. So this is n, here is 100, so it is 100 into 101 by 2. We know the formula, n into n plus 1 by 2 minus 1 to 50. Here n is 50, so n into n plus 1, that is 2. You can solve it. Take this 2 common here because it's 100, so you can directly multiply also. Do it 10100 minus 5 ones are 5, 5 5s are 25, 2550 by 2. So this is 10 में से 5 and this is just cancel 10 minus 5 and 10 minus 5 again 5, right? 9 minus 2 7, so half it, it's going to be 3 7 7 5. So this is the answer, right? Yeah, 3 6 7 and 7 and 5. Yeah, this is the answer of this beautiful question. So this is the concept of this. All right, next. Okay, the last question of the day, of the video, you can say. So of this video, so 8485, which is completely divisible by 75. Now you know the rule of 75. It is number has to be divisible by 25 as well as 3. Now what is the rule for 25? The rule is the last 2 digits must be divisible by 25, right? And 3, you know, the sum of the digits. Sum of the digits must be divisible by 3. Then only we can say the number is divisible by 3. So pick up which natural number is nearest to this. So let's pick up last 2 digits. We check for 25. Why? So because 25 is nothing but 5 square. So that's why we check the last 2 digits. Now focus. This has to be 25. So if you see, first option is correct. Last 2 digits are divisible by 25. Then 0 0. So all these are correct as per 25. So that means we need to check it for 3 now. So check for 3. It is 8 plus 5 13. 13 plus 2 15. That is fine, but 5 is left. So this is not divisible by 3. For 25, all the options are satisfying. All the options are cancelled. Okay, next 5 5 5 5 10 and 18. Yeah, this is cancelled. Fine. But we need to check nearest to 8485. So this is not that nearest as this. So let's check 8 plus 5 13. No, it's not cancelled. So sum is not divisible by 3. Okay. Now check this. 8 plus 4 12. 7 and 5 12. So this is also cancelled. But we need to check the nearest number. So the nearest number is 8475. Right? So what is the answer? The answer of the question is 8475. So this is the way we solve these questions.